Hi students, in this lecture I will discuss concept and calculation of nodes and lobes. Normally, nodes means where probability of finding of electron 0 in an atom. I am repeating, nodes means where probability of finding of electrons 0. And lobes means part. That means parts of orbital is called lobe. Clear? Let's start nodes. Look at both nodes. The point or region or plane. The point, region, plane. In definition, the point, oblique region or plane inside atoms where probability of finding of electron 0 are known as nodes. I am repeating, the point, the area, the region, the plane inside atoms where probability of finding of electron 0 are known as nodes. When electron density 0, probability of finding of electron 0 are called nodes. In definition, there are three terms: point, region, plane, and hence there are three types of nodes. Mainly two types, but there are three types of nodes. One is nodal point. Second is radial node. From point, one nodal point. From region, radial node, and from plane, planar node. There are three types of node. One is nodal point. Second is radial node, and third is planar node. I will discuss step by step. First, nodal point. Look at both. Nodal point. The point inside in an atom. The point, not region, not plane, only one point. The point inside in an atom where probability of finding of electron 0 called nodal point. And we know that nucleus is central point of each atom. In each atom, nucleus situated at central point, and in nucleus all protons and neutrons present. That is, all protons and neutrons of an atom situated at central point, and this central point is called nucleus. And we know that nucleus contains total proton, neutron, and electrons move around the nucleus in different circular, elliptical, and three-dimensional terms called orbit, suborbit, orbital. That is, nucleus do not contain electron. In nucleus, probability of finding of electron always 0, and hence nucleus is also called nodal point. Always keep in mind, second name of nucleus is nodal point, because node means where probability of finding of electron. Nucleus is a point of an atom, and central point where probability of finding of electron 0, and hence nucleus is called nodal point. Clear? Nucleus is called, example, nucleus. Example of nodal point, nucleus. Next, second is radial node, spherical node. Two names most popular, radial and spherical. Third type of node is angular node and planar node, and hence radial spherical, and it is not angular, called non-angular. It is not planar, also called non-planar, but two names most popular, radial and spherical. And listen, the spherical region around the nucleus of atom, the spherical region around nucleus of atom, where probability of finding of electron 0, because we know that node means where probability of finding of electron 0, and spherical means the spherical region around nucleus where probability of finding of electron 0. Clear? Clear? Now, next. Number of radial nodes or planar nodes. Formula of radial and planar nodes is equal to n minus L minus 1. N minus L minus 1. I am repeating. N minus L minus 1. Where n is principal quantum number and L is azimuthal quantum number. Clear? Where n is principal quantum number and L is azimuthal quantum number, 1 is constant. Now, one table for your question, orbital, number of radial node, formula n minus L minus 1. Look at book. 1s, for orbital 1s, number of radial node, 1, n is equal to 1, and for s, L is equal to always 0. For any s, 1s, 2s, so 1 minus 0, and in formula of minus 1, so 1 minus 0 minus 1 and 0, and hence 1s has 0 radial node. Any 1s has no any radial node. Second, 2s, formula n minus L minus 1, 2 minus, for s L equal to 0, so 2 minus 0 minus 1. N minus L minus 1, 2 minus 0 minus 1 is equal to 1. Sorry, is equal to 1. And hence 2s has 1 radial node. Now 3s, formula is n minus L minus 1. The n is 3. For s, L is equal to 0. 3 minus 0 minus 1, and it is equal to 2. Now for 4s, formula is n minus L minus 1. N 4 minus L, for s, L is equal to 0 minus 1, it is equal to 3. For 5s, 5 minus L, for s, L always 0 minus 1, it is equal to 4. And hence for 1s, number of radial node 0, for 2s, number of radial node 2, for 3s, number of radial node 2, for 4s, number of radial node 3, and for 5s, number of radial node 4. Again I am repeating, 1s, radial node 0, 2s, 1, 3s, 2, 4s, 3, 5s, 4. Now, for p orbital, listen, for p we know that L is equal to 1, and for radial node n minus L minus 1, and for any p, L is equal to 1. For 2p, the n is equal to 2 and L is equal to 1, the 2 minus 1 and minus 1 is equal to 0. That means 2p orbital has 0 radial node. Now 3p, n is equal to 3 minus L, the L 1 for p and minus 1, and it is equal to 1. For 4p, n is equal to 4, for p, L is equal to 1. The 4 minus 1, n minus 1, it is equal to 2. Clear? Now, for 5p, n is equal to 5, L is equal to 1 and minus 1. And hence, 5 minus 1 minus 1, and it is equal to 3. Now for any D, for D, L is equal to 2 and radial node is minus L minus 1. So for 3D, 3 minus 2. Why 2? Because for D, L is equal to 2 minus 1, it is equal to 0. For 4D, for D, L is equal to 2 minus 1. So 4 minus 2 minus 1 and it is equal to 1. For 5D, N is equal to 5. D, L is equal to 2 minus 1. 5 minus 2 minus 1 and it is equal to 2. For 4F, and we know that for F suborbit, L is equal to 3. For 4F, 4 minus 3 minus 1, 0. 5F, 5 minus 3 minus 1 is equal to 1. And it is stable for number of radial node. But always keep in mind, formula of radial or a spherical node is equal to n minus L minus 1. N is principal quantum number, L is azimuthal quantum number and 1 is constant. N minus L minus 1. Now, I will explain to planar node. Planar node. Look at board. Planar node is also called nodal plane. Planar node, nodal plane, and also called angular node. There are three popular names: planar node, nodal plane and angular node. But it is not radial, the non-radial node and non-spherical and hence called non-spherical node. 5 names, 3 most popular: planar node, nodal plane, angular node, non-radial and non-spherical node. And definition is, listen carefully, the plane passing through the nucleus of atom, the plane passing through nucleus of an atom where probability of finding of electron 0, known as planar node or nodal plane. I am repeating, the plane passing through nucleus of an atom where probability of finding of electron 0, called planar node or nodal plane. Look at both. The plane passing through the nucleus where probability of finding of electron 0, called nodal plane or planar node. Clear? Listen, about plane, there are 3 axes, x, y, z. XY plane, look at board. In between x and y, this x and y, the xy space, the plane xy axis between, in between x and y, the plane is called xy plane. In between y and z axis, called yz plane. In between z and x axis, called zx plane. Clear? Clear? Again, xy plane, the plane between x and y axis; yz plane, the plane between y and z axis; zx plane, the plane between z and x axis. Now, number of nodal plane or number of planar node is equal to L. Number of nodal plane or number of planar node is equal to L, and L is azimuthal quantum number. We know that for any S suborbit, L always 0, and hence for any S orbital, number of planar node 0, because S has a spherical shape and in all plane electron moves, and hence a sphere has no any nodal plane. Look at board. For any S suborbit, L is equal to 0, and hence number of nodal plane equal to 0 for any S. Any S means 1s, 2s, 3s, 4s, 5s, dot dot dot, all have 0 nodal plane. Clear? Next, always keep in mind, nodal plane is equal to L and radial node is equal to n minus L minus 1. Next, Listen, spherical. It is a spherical shape and for S. When a spherical, then electron moves in between X and Y, between Y and Z, between Z and X, and hence a spherical shape has no nodal plane because in each plane electron moves. Yes or no? In each plane electron moves and hence a spherical shape has no any nodal plane. Clear? Any S has a spherical shape, no nodal plane. And for P, azimuthal quantum number 1, a number of planar node is equal to L, and hence for any p orbital, and we know that p has 3 orbitals, one px, and we know that px means dumbbell lie on x-axis, second orbital py, and py means dumbbell lie on y-axis, and third orbital is pz and dumbbell lie on z-axis. Look at both. In case of px, look at both. Px, dumbbell lie on x-axis, and when dumbbell lie on x-axis, then between y and z-axis, probability of finding of electron 0. I am repeating. When dumbbell lie on x-axis, that means dumbbell lie on x-axis, then probability of finding of electron between y and z is equal to 0, and hence for px orbital, yz plane is called nodal plane. Number of plane is 1 and name of plane is yz, and yz plane is nodal plane for px orbital. Now, number 2, py orbital. And py orbital means dumbbell lie on y-axis. And when dumbbell lie on y-axis, then between x and y, listen, when dumbbell lie on y-axis, then between z and x, probability of finding of electron 0. I am repeating, when dumbbell lie on y-axis, then between z and x, probability of finding of electron 0, and hence for py orbital, zx plane is called nodal plane. Zx plane is called nodal plane for py orbital. Clear? I am repeating. Any p orbital has one nodal plane. For px, yz plane nodal plane. For py, zx plane nodal plane. Now, for pz, pz means pz orbital means dumbbell lie on z-axis, and when dumbbell lie on z-axis, it means electron may be found between yz, zx, but never found between xy, and hence for pz orbital, xy plane is called nodal plane. Xy plane is called nodal plane. Clear? I am repeating. For any p orbital, nodal plane 1. For px, yz plane nodal plane. For py, number of nodal plane 1. Zx, for pz, number of nodal plane 1. And pz, for pz, xy is nodal plane 1 table. Orbital, nodal plane, name of plane. For any px, 2px, 3px, 4px, 5px, for any px, number of nodal plane 1. And name of plane, when px, then yz plane, nodal plane. For any py means 2py, 3py, 4py, 5py, 6py. Number of nodal plane 1 and name of plane zx. And for any pz, and any pz means 2pz, 3pz, 4pz, number of nodal plane 1 and name of plane xy. Clear? Now for d orbitals. We know that for d orbitals, L is equal to, for d orbitals, L is equal to 2. Hence, each d orbital has 2 nodal plane except dz square. Dz square has 0 nodal plane because dz square has baby Suter shape and one orbital. In case of dz square, one orbital on z-axis and other orbital rotate along z-axis. Look at both. One orbital on z-axis and one dumbbell and other dumbbell rotate along z-axis, rotate along z, and hence in each plane electron found, and hence for dz square number of planar node is equal to 0, and for each d orbital number of nodal plane 2 except dz square. Why? Because in dz square each plane contains electron. Electron found in each plane, and hence dz square has 0 nodal plane. Clear? Next, orbital any dxy, any 3dxy, 4dxy, 5dxy, for any dxy number of nodal plane 2. And dxy means, we know that dxy means both dumbbell lie between x and y. Both dumbbell lie between x and y. So when both dumbbell lie between x and y, then yz and zx plane are called nodal plane. Clear? For dxy, number of nodal plane 2, yz and zx. For yz, any yz, 3d yz, 4d yz, 5d yz, number of nodal plane 2, and in case of yz, both dumbbell lie between y and z axis. Both dumbbell lie between y and z, and hence xy and zx are nodal plane. For any dzx, and dzx means both dumbbell lie between z and x axis, and for any dzx, number of nodal plane 2, and name xy and yz, and for any dx square y square, and dx square y square means one dumbbell on x axis, other dumbbell on y axis, number of nodal plane is equal to 2, but name of plane cannot be calculated, name of plane cannot be predicted, but number of plane will be 2, and for any dz square, that means 3dz square, 4dz square, number of nodal plane 0, because dz square has this type of a structure and this type of diagram, and in dz square, one dumbbell lie on z-axis and other dumbbell rotate along z-axis, and hence each plane found electron, and hence dz square has no any nodal plane. Clear? I am repeating. Any d orbital 2 nodal plane except dz square. Any dxy, 3dxy, 4dxy, number of nodal plane 2. In case of xy, yz, zx are nodal plane. Second, any dyz, 3dyz, 4dyz, number of nodal plane 2, and in case of yz, xy, zx are nodal plane. For any dzx, that means 3dzx, 4dzx, 5dzx, number of nodal plane 2, and plane will be xy, yz. And for any dx square y square, that is 3dx square y square, 4dx square y square, number of nodal plane 2, but name of plane cannot be predicted. And For dz square, 0 nodal plane, and because diagram of dz square is this, and one dumbbell lie on z-axis, other dumbbell rotate along z-axis. Clear? And now I will discuss total nodes. Total nodes. And total nodes means summation of radial nodes and planar node. That means a spherical node and planar node is equal to total nodes. Topic is total nodes. Total nodes means spherical plus planar. We know that formula of spherical n minus L minus 1. Formula of planar L, n minus L minus 1 plus L, L cancel, and hence formula of total nodes is equal to n minus 1. Formula of total nodes is equal to n minus 1. Always keep in mind total nodes n minus 1. Now for orbitals detailed form, how many total nodes and in total how much spherical node and how much planar node. Look at both. Orbital formula total n minus 1, radial and planar. And always keep in mind S has no planar node, any p orbital 1 planar node, any d orbital 2 planar node except dz square. And formula of radial node n minus L minus 1. Look at both. 1s orbital, total node n minus 1. So 1 minus 1 0. When total 0, that means radial 0, planar 0. Now 2s, n minus 1, the 2 minus 1, the 2 minus 1 1. So for 2s total node 1 and total node 1 for 2s, and which one is radial because S has no planar and hence 1 is radial for 2s. For 3s, total node 3 minus 1 and hence total node is equal to 2. But both are radial because we know that S has no planar node and hence 3s has total node 2. Both are spherical node, both are radial node and 0 planar node. Now 4s. For 4s, total node 4 minus 1, 3. And all 3 are radial because S has no planar node. Clear? Now, for p orbital, 2px, 2py, 2pz. For any p, planar node 1. Always keep in mind, for any p, planar node 1. For px, 1 planar node, but name of plane yz. For py, 1 planar node, name of plane zx. For pz, 1 planar node, name of plane xy. So, for 2px, 2py, 2pz, total number of nodes 2 minus 1, 1, and 2p has no radial node and hence 0 radial and 1 planar. Clear? Because p has always 1 planar. Now, 3px, 3py, 3pz. Listen, total node n minus 1, the 3 minus 1, 2. But 3p has 1 radial and 1 planar. Always keep in mind, p has 1 planar, the rest will be radial. So 1 planar, 1 radial. When 4px, 4py, 4pz, so 4 minus 1, 3. And when 3 total nodes, then 2 will be radial and 1 will be planar. 5px, 5py, 5pz. Total node 5 minus 1, 4. 3 radial and 1 planar. Clear? Now D. 3dxy, 4dxy, 5dx. Sorry, 3dxy, 3dyz, 3dzx, 3dx square y square. 3D. Total node n minus 1. 3 minus 1, 2. And both are planar because 3D has 0 radial node and both are planar. In case of 3dz square, formula not applicable because dz square has 0 planar and hence total node of 3dz square. Formula of total node n minus 1 not applicable for dz square because dz square has planar node 0. And hence n minus 1 not applicable for dz square for planar. In case of total node of dz square, that means 5 dz square, 5d, the 5 minus 1, 4. The 4 total node, radial planar, but planar of dz square 0, and hence for 5 dz square, total node will be 2 and both are radial. Again, 4dxy, 4dyz, 4dzx, 4dx square y square, 4d. Total node 4 minus 1, 3. And we know that d has 2 planar and 1 radial. But in case of 4 dz square, total node 4 minus 1, 3. But we know that in 3, 1 radial, 2 planar, but for dz square planar 0, and hence not 4 dz square, total node is equal to 1, not 3, because when by formula it will be 3, 1 plus 2, but planar node of dz square 0, and hence total node is equal to 1, because diagram of dz square of this type, and hence no planar node. Clear? Clear? Now, topic lobes. And lobes means part. Lobes means part. And each p orbital has 2 lobes. Listen, this is dumbbell shape for p orbital. It is one part of electron density and it is other part of electron density. And this part is called lobe, and hence each p orbital, one part, other part, lobe, py, one part, other part, lobe, pz, one part, other part, lobe. And hence each p orbital has 2 lobes. Each p orbital has 2 lobes. Next, each d orbitals has 4 lobes. 4 lobes except dz square. Listen, in case of d, listen, double dumbbell shape, one dumbbell, second dumbbell, third dumbbell, each d orbital has 4 lobes except dz square. In case of double dumbbell, one part of electron density, other part, third part, fourth part, and hence d orbital has 4 lobes. dxy has 4 lobes, dyz has 4 lobes, dzx has 4 lobes, and dx square y square has 4 lobes. But in case of dz square, only 2 lobes. And hence, if in a question it is given which d orbital diagram completely different with respect to another d, the dz square has different diagram than other d, because other d has 4 lobes and dz square has only 2 lobes.